Has anyone here?
Okay, I'm gonna start now. It's 7:01. I gave people time. Where the heck? Okay.
I got you. Okay.
Okay, wait, hold on, wait. Where the heck is the? There it is. Okay. Ooh, that's cute. Okay, hi everyone. Welcome back to another meeting. So the calendar events we have updated. You found your way here today, so you know what today is. Halloween. Oh, can you get Josie? Thank you. Halloween is Sunday. Hope you know Halloween Sunday. Hmm? Oh, shoots. Yeah. Yeah, that actually is important. Thank you. Yeah, I forgot about that. That's how my memory's going. Skywarn is on Saturday, October 30th, 9 to 11 a.m. I will talk about it. There's a slide coming up. It's virtual only, so you can do it in your pajamas in bed if you would like. That's what I plan on doing. And then we have another meeting, 2 weeks, same place, same time, same Tuesday. And then the 11th, we have the day off, so it'll be game night. I forgot to go back to the video and get the list of games Split had. So we'll vote on that on the 9th, of what games to play, because I totally forgot to do that until this moment. And then we have another slide talk about this, but whoever is going to the AMS conference in person, there's a mandatory meeting on November 16th to discuss how we're getting there, getting to Houston. We are not walking, although AMS wants us to be carbon friendly. We are not walking though, except bacon. They want us to like walk. What?
They want us not flying to Houston.
It's only a 15-day walk.
Yeah.
Why don't they want to?
They want us to save carbon. Our carbon footprints.
I don't know.
So yeah, Skywarn's this Saturday, 9 to 11 a.m. Zach sent out the form you have to fill out to register for it. He sent it out when he sent this meeting reminder.
Damn, that joke is.
I really like that joke. I'm sorry.
That's something right there.
Good joke, Kelly. I like it. That's cute. So you have to fill out a Google form that the NWS wants you to fill out. For the address, if you don't live in the NWS Melbourne WFO, you need to use the school's address. Like Matt lives in Pennsylvania. He does not live anywhere in the NWS Melbourne thing. So you use the school address for that. And the day before, they're supposed to send an email out with the link. It's on Go webinar, I'm pretty sure. So if you need to register and you don't have the link, how many of you have not registered yet? Let's go over there. Baby.
I can do it tonight.
Okay, well, that's fine. Well, if you've, yeah, this is the basic one we're doing because you have to do the basic and then you can do the advanced, which is more fun, in my opinion. You have to do the basic first, except that one time. That's what I said to do it. That one time where they let us do the advanced because the basic got canceled because of your weather. There's no weird weather right now, ironically. Well, Thursday, yes, but not today. Oh my God, that gift is cute. Sorry. We still need to confirm this because there's glitches going on. But if you wanted to attend the AMS meeting virtually, you can. However, the website is not letting you register for the student conference virtually. They will get back to me because I asked them.
I tried like 3 times.
Yeah, Cheryl brought it up and I pinged them on Twitter and they said that they're trying to look into it because there should be a virtual option. So the student conference is $60 for students, and if you want to do the main conference, which is the week-long conference, and see me present, that's $165. So if you want to go to the conference, just go. You have to be an AMS member to get these, and it's $20 a year for students. So if you're not an AMS member, you should register for the National AMS chapter if you haven't yet. If you look up the basically American Meteorological Society, you can register there. So. And then Panther weather, we're still doing our forecast. There's Karsh. We're still working on it. We're in the process of almost getting a place to do it now. I had a meeting with Dr. Key on Friday about it, and they have cameras and Thank you, baby. You registered. Good job. They have microphones and cameras, so we'll have to end up finding a way to get green screen lighting and a computer/video encoder. Did I miss someone? No, I didn't. Okay, I thought I saw something pop either a computer or a video encoder. I have a meeting with the Crimson tomorrow because instead of working with FITV, since they really don't want to work with us, I don't know why, but we're probably going to house with the Crimson, and they'll probably end up putting our forecast on their website. I have to talk with them tomorrow, so more details will be forthcoming, but we've been doing it all on Zoom and Karsh's creative ways of using a screen and doing the forecast that way. So it was just an update on that. There we go. And wow, oh, you put it in the Okay, so now none of you came here to see me talk. No one ever wants to see me talk. We're maybe enough. So now we have Will Ulrich. I don't know his friend. I'm sorry. Who are you?
I'm Bill.
Are you his brother?
No, it's my partner.
Oh, I thought they're like Will Bill. And so yeah, now he's going to speak to you. He's a launch weather officer at the Cape Canaveral Space Force Station. So let me put your PowerPoint up there. Yeah.
Hey guys, so who saw me talk last year or earlier this year? What feels like a year ago? So most of you. Okay, so cool. It's good to see you guys all again, and you know, I'm happy to be here. Who has plans to go to the American Meteorological Society conference out in Houston physically? Physically. Wow. Okay, I will probably be going, so it'll be good to see you out there. Make sure I get your contact information. We can see one another. If you're presenting in particular, I'm going to arrive Sunday. If you're presenting in any student stuff or there for the week, let me know. See you out there. It has been a long time since I've been in the hallowed grounds that are the Link, and that is the Link building. So it's kind of weird to be in here. This used to be the Synoptic Lab, or this is now the Synoptic Lab. This is
Still the Synoptic Lab.
And you did when I was here, and it's been like this long. I feel like there were like rows of computers in here.
Yeah, they got rid of them like 2 weeks ago.
Oh, okay. There used to be anyway. So as you can see on the bottom of the screen there, it's been a while since I've been here because I graduated initially in 2008 with my Bachelor's of Science, and in 2011, my Master's in Science. I forgot I got people on the Zoom call. Hello, Zoom call. So I'll try and look over there every now and then. These are just some cool images of recent rocket launches that we've had. And I know a lot of you guys are particularly interested in space, not just from the meteorological component to it, but because of what's happening in the commercial industry. So new companies that are coming online like Blue Origin and Relativity, new companies that have been around for a while, not really new anymore, SpaceX, Elon Musk, are all either already on Cape Canaveral property or will be soon. And so the landscape of how we launch rockets is changing rapidly every single day. And it's to the point where with time, while we're averaging between 40 and 50 launches per year right now, the anticipation is that we'll be in excess of 90 to 100 launches. And that's mainly because we're going to have a lot of small rocket companies that are about to come online in the next year or two that are going to do low Earth payloads, low Earth orbit payloads. Small cube satellites. For some reason, everybody wants to launch tiny cube satellites into space for communication and constellation activity. So with time, we're not going to see a lot of these big rockets necessarily, any more of these big rockets aside from Blue Origin's New Shepard or New Glenn that's going to be coming online next year. We're actually going to start seeing smaller rockets come on board, and they're going to launch a lot more frequently. So obviously, as the landscape changes, so too does the 45th Weather Squadron. And those are some of the things that I'm going to talk about today. But I'm also going to hit on the history. So you guys probably heard some of this last time, but I want to reiterate some of it and talk about some new points since I've learned in the past 10 months since I've seen you all. Most of you probably remember my background, other than the fact that I'm this is my alma mater here at FIT, 2008 with my bachelor's, 2011 with my master's, working under the auspices of Dr. George Mall. May he rest in peace. He passed last year. Did I hear? Okay, so I know he passed recently. Dr. Chow, and of course Dr. Lazarus and Mr. Split. So lots of stories, and it's really neat to be back. Born and raised in South Jersey, right outside of Philadelphia, about halfway in between Philadelphia and Atlantic City. And I was lucky enough to know that I wanted to be interested in meteorology ever since I was a kid. I'd say 6 or 7 years old. I was constantly looking up. My parents thought something was wrong, but they realized that I wanted to be a weatherman pretty early in the game. And so lots of storms stand out in my history, in my recollection as a child, but the big ones were the March 1996 superstorm that led to a big blizzard on the East Coast. 1990. Oh my God, do I even ask this question? Who was born in 1990? Oh my God. Yeah, because it's 2021. So you're all born in the 2000s?
I was born 99.
Okay. Oh my God. All right. Anyway, the March 1996 blizzard dumped 36 inches at my house. Awesome. And March 1993 superstorm. I was only 8 years old, but I remember it vividly. It led to a big rain-snow mix along the I-95 corridor. And my parents and I were down in Atlantic City, got trapped because of the storm surge associated with the large extratropical low pressure system. And I'll never forget how much rain fell in Atlantic City, but we drove 25 miles inland to where I live, and there were 12 inches of snow on the ground. So I couldn't get over the fact that there was such a difference between such a small distance, and I was fascinated. That's the February 2003 blizzard that led to something like 23 or 25 inches. That's my car under that little mound that you see there on the right-hand side. So, you know, we didn't really have tropical storms very often. I could think of a few. Bob, 1991, Bertha, 1996. I wasn't there for Sandy. But I would say, you know, between a couple tropical systems and the big nor'easters, that's really what solidified my love for weather. I moved down to Florida in 2004 to start here at FIT, graduated in 2008 and started an internship with the National Weather Service office in Melbourne. Worked there for a year while I was doing my grad school studies, and the National Weather Service office in Key West hired me. A couple of those pictures there, the crystal blue waters. We went out and worked on some of the the marine, what are they called? The permanent buoys, kind of like lighthouses. I don't really know the name of those things. But obviously we had weather stations affixed to those permanent, you know, buoys, if you will, out there. And so we would go out there and service them. And I'll never forget how crystal blue that water is down there. You think the water's kind of nice here? It is really, really nice down there. A couple tropical storms impacted the Keys while I was there in the 2 years. That image is from Hurricane Isaac. Really, our winds only peaked out at about 70 miles per hour, so it didn't even technically make hurricane status when it passed the Keys. Went back to the Melbourne office from 2013 through 18, about 2 years ago. I decided to get out of the Weather Service game and join the United States Air Force as a civilian. That is, who is responsible for forecasting for launches at Cape Canaveral. Well, at least it used to be, until Donald Trump decided to create the United States Space Force. And once the Space Force was created, we got assigned to the Space Force. So technically, my paycheck still comes from the Air Force, but we are part of the United States Space Force. And you might be familiar with the fact that Patrick Space Force Base was recently renamed right to the Space Force Base and not here. It was the second site to be named as Space Force Base, in addition to Vandenberg, which also launches rockets out on the West Coast of California, a little ways outside of LA, okay? So here we are. The United States Space Force created just about 2 years ago. For the longest time, the 45th Weather Squadron was under the United States Air Force, under the Air Force Space Command, of which the 14th Air Force was a part of. We fell under that, the 45th Space Wing. We're no longer the 45th Space Wing. In fact, I forgot to update this. We are now Space Launch Delta 45. That is the makeup of who we are at Patrick Air Force, Space Force Base. United States Space Force, we work under the Space Operations Command, Space Launch Delta 45, we're underneath the 45th Operations Group, and there is the 45th Weather Squadron. So some things have changed. As you can see, Air Force Space Command basically took over as the new branch of the military that was created 2 years ago as the United States Space Force. And then the 14th Air Force became Space Operations Command, which we now fall under. So you can kind of see how those things are tied together. So before I get into the history of Cape Canaveral Space Force Station and Kennedy Space Center, you guys have any questions for me?
I'm from Marathon, Florida, and I was interested in possibly interning in Key West over the summer. How's your experience of the Key West National Weather Service?
Well, you should do it. Anyone in this room, if given the opportunity, who can volunteer either at the Melbourne office or the Key West office. I know things are probably difficult because of COVID and all that stuff. If you can, you should. even if I had problems in Key West or I said negative things about Key West, which I'm not, you should still take the opportunity, right? I'm assuming you're going to be down there during the summer, the upcoming summer. You absolutely should. And just remind me, Cassie, remind me, I'll send the contact information for who is responsible for allowing student volunteers in. And it's a unique site, right? It's the only site completely, do I have a map? Yeah, kind of. It's the only National Weather Service site that only has one zone to forecast for. One zone is basically like one county to forecast for, and that's the entire stretch of the islands from Key West all the way up to mile marker 118, just south of, Homestead. So it's the only National Weather Service office that basically is responsible for just the island chain. Miami is South Florida, Tampa is West Central Florida, the Melbourne office is East Central Florida, Jacksonville is North Florida, Tallahassee is the Panhandle. Okay, so whereas all the other National Weather Service offices have like 10 to 15 counties to be responsible for, some even more, depending on the size, US is responsible for just the activities that go on along the island chain, in addition to all of the water. So obviously they have a heavy marine influence. So if that interests you at all, I think you would learn a lot. During the summer months, you probably know, the number of water spouts that occur there are unlike anything else that occur on the planet. So at the very least, you would certainly learn a lot about the mesoscale activities, probably even smaller than mesoscale, that go on to create water spouts. So yes, you should do it. What year are you in now?
Junior year.
So you got one more shot. You guys not do summer projects anymore?
No.
Oh, Jesus. Summer projects ruined our summers, but we had the best friggin' time. So obviously there's a storied history to Cape Canaveral Space Force Station and the Kennedy Space Center. And why am I showing this map again? Ignore the text that's on top of it, but the map that you see here, or the image, the satellite image that you see, covers all of Cape Canaveral Space Force Station. What you really can't see in this image is the Kennedy Space Center, which owns property on Merritt Island. So they are two separate entities. So when I talk about, if I ever mention the Eastern Range is everything combined and all of the tracking stations that are downstream of Cape Canaveral. So tracking stations in the Bahamas, tracking stations all the way off the coast of Africa, Ascension Island, thousands and thousands of miles away. Those are part of the Eastern Range. In other words, where we launch the rocket from and where those rockets go to, where we no longer track them before they get into suborbital or orbital space, that's the Eastern Range. But I just wanted to show this map because Cape Canaveral Space Force Station covers the part that's closer to the Atlantic Ocean. Kennedy Space Center, for the most part, covers all of Merritt Island. And part of the area, pads 39A and 39B, those are also Kennedy Space Center property. So just to make sure everyone is familiar with the fact that Cape Canaveral Space Force Station and Kennedy Space Center are two separate entities. Cape Canaveral Space Force Station being run now by the Space Force, for the longest time the Air Force. Kennedy Space Center was always run by NASA ever since its inception in the 1950s, 1958. Okay? But when did the government start to have a presence on the land that is now Cape Canaveral Space Force Station? Who has been out onto the site? Kelly, don't raise your hand, I already know the answer. Two. How many times have you been to the office now? How many times have I seen you? So, do your dad still work at the Mock or not?
Yes, but he's retired from the Air Force.
Okay, that's right. I kind of remember that. So, in some format, so if you haven't been there, here's what I would say. Yes, I'm hoping, and I was going to open the invitation for you guys. If you'd like to maybe even have a meeting up there, why don't you come up for a tour and we can actually go and visit some of these sites. I think we're going to have to limit the numbers and probably keep it under 15. So, we got to keep that in mind. So I think with the way things are opening up, my commander, Colonel King, would allow a tour of you guys to come in. At the very least, do you guys have access to like a large van or a bus of some kind that we could drive on base? Obviously, might have to pay. No, here that you would have to bring up to on base. So think about it. Because what I find most interesting about the area that I work at is that, some of this history that I'm going to talk about. When the first Bumper V2 rocket was launched in 1950, which was the first rocket to leave the Cape, when the first satellite was launched, Explorer 1, where Alan Shepard launched the Mercury Freedom 7 on top of a Mercury Redstone rocket, where John Glenn launched. All of those sites are still there. And so you can walk on the paths that launched these very historic missions. Maybe don't mean a whole lot to you now that we're 60, 70 years past. But when you look back and see that all of this land is still there, and unfortunately, obviously, through time, things don't look the way they do, but you can compare pictures of what they look like now and see how much the vegetation and stuff has grown through the years to what they used to look like back in these during the historical era that is the 1950s and 1960s. So I will open that invitation. I've already talked to the Colonel and let him know that I'm thinking about allowing FIT AMS to come up, and I hope you guys take me up on that offer. If we can't do it this spring, we should consider it for next year. We're starting to open back up for COVID, and based on the trends, I don't see why that would change anytime soon. Okay, that was a sidebar. Squirrel. So here we go. 1847, believe it or not, United States Coast Guard decided to build a lighthouse on the property. Now, at the time, did they know it was going to become the rocket capital of the United States? No, of course not. But notice how the land juts out, right? The land juts out. Obviously, it was a navigational concern all the way back in the 1800s. The United States Coast Guard bought the land on the tip of the Cape and built a brick structure that became the Cape Canaveral Lighthouse. Funding was approved in 1843, and it wasn't finished until 1847. It was dismantled in the 1860s during the Civil War, but there were already plans to replace it with a more sturdy steel structure in the 1860s. And in 1868, the second version of the lighthouse was completed, but in the same exact spot that the first one was built. 30 years later, they had to move it because of coastal erosion. So believe it or not, the original picture that you see here, it was moved about a mile inland. In 1898, and in that location, it still stands. It has not moved since. And it's the same structure that was built in the late 1800s. So it's pretty fascinating to see a permanent structure from the late 1800s. It stayed that way for almost 40 or 50 years after 1900. It wasn't until the late 1940s that President Truman decided to establish what was known then as the Joint Long-Range Proving Ground. After World War II stopped, we grabbed all the available smart people from Germany who were very good at the time at building rockets, including this guy named Werner von Braun, who eventually went on to head NASA and helped build the Apollo mission, or helped build the Apollo rocket, which is the Saturn V. Germany fell, what, 1945, 1946? In the late 1940s, we were starting to develop our own rockets, but we did that at the Missile Proving Ground out in White Sands, New Mexico. We needed a second spot, kind of a backup spot, to launch these rockets. And so they started to look at 3 locations: Washington State, Northwest Washington, yeah, the state north of Oregon, Southern California, far Southern California, right near the border of Mexico, and then, sure enough, lowly little Cape Canaveral, the swamp that is Cape Canaveral. Originally, we were going to launch all of our rockets from California, and we were going to send them out in the Pacific, and we were going to send them down the coast of the Baja of California. But something happened in 1947. 1947, they attempted to launch a rocket that went, kind of an early version of the V2, went up, and something went wrong. And it started to go off course, and it crashed into a home that was responsible for a cemetery in Mexico. Suffice to say, they probably weren't very happy with that outcome. So they were incredibly angry, especially the fact that it fell on hallowed grounds of a cemetery in Mexico. You know, the whole dead thing, right? They take that very seriously. So you blow it up, 50 by 50 foot hole in the ground in Mexico. Kind of started this big talk about what's the future of rockets at White Sands Missile Launch Range. Well, believe it or not, that incident alone canceled the plan to have the missile proving ground in California. And after that incident, the Mexican president said, no, you're not going to build it there. We don't want you to send any rockets south, not over the water or anywhere near the Baja. And sure enough, they chose Cape Canaveral as the site to start building rockets. So a lot of history that went on after World War II to help make kind of Cape Canaveral the breeding ground for what eventually turned into, the busiest launch site in the world. 1940s and 1950s were mainly for developing intercontinental ballistic missiles, those missiles that could travel very far, but not yet into space. The first launch of a missile was the Bumper V2. The V2 is Wernher von Braun's first rocket that he helped develop during the war and World War II in Germany. And so it was just a better version of that, because at that point in 1950, we had already stole von Braun from Germany, and we kind of used his incredible brain to help develop our own rockets, and that was the first launch in 1950. Took a couple years, but in 1958, through the 1950s, we decided to change from just using rockets for death and destruction and potential for death and destruction for space exploration. Scientists said we really need things up in space to monitor what is going on here on the ground. And if we have it from space, we can constantly be monitoring things. So Dwight Eisenhower, back in July 1958, signed what was known at the time as the National Aeronautics and Space Act. October 1st of that year, NASA was created. So we were no longer building rockets for wartime capabilities. We were now starting to discuss launching satellites into space. And that first example of a satellite was Explorer 1 in, I believe, December of 1958. It was launched on a Juno rocket, which is a very early prototype of an intercontinental ballistic missile that was retrofitted to become a suborbital rocket. And that launched from Complex 26, which, by the way, is still there. 1961. A lot of things had happened after NASA was created in October of 1958. On May 5th, 1961, Alan Shepard launched aboard the Mercury Freedom 7, which was on top of a Redstone rocket, which, believe it or not, in the 1950s had been originally created as a bomber rocket. We were going to put bombs on top of all of our rockets. Did we ever think we were going to put humans? Well, once scientists came along and created NASA, yes, we were going to start putting humans on top. But we had to do it iteratively. This was the first time we were ever thinking about sending up people into space. But who did it first? Russia. Yuri.
USSR.
Yuri Gagarin, right? Launched. Well, not this. Ooh, I don't have the date on here. Damn. Don't remember when he launched. It wasn't long before Alan Shepard. We were kind of working in sync because about a month before we launched Explorer 1, the first satellite, they launched Sputnik. Yes. So we were kind of in this race to send up either the first satellite or the first human. It wasn't until 1961, May 5th, 1961, that we launched Alan Shepard. And just 20 days later, John F. Kennedy gave that very historic speech where he said we were going to put a man on the moon and then land him back here on Earth. But he waited to do that until after Alan Shepard completed his first suborbital flight. Suborbital, what's that mean? He just goes up into space and comes back down. He does not orbit the Earth. So he went up there for 15 minutes. I guess John F. Kennedy said, okay, that's enough for me, we're going to space. The Mercury missions were used to see if space was safe for humans. Gemini, which came next, basically tested humans' abilities to do things in space, including spacewalks. And then Apollo, which kind of went iteratively, right, from Mercury to Gemini to Apollo, the ultimate goal was to get to the moon. So we did these things in steps. I know this isn't about meteorology. Some of you guys are like, what the hell are you talking about this? But again, if you come out to the site, you'll understand why I'm so interested in some of this stuff. Because the site where Alan Shepard launched, you can literally stand underneath a prototype rocket that is still there. You can see what the size of the rocket is. The exact size rocket prototype is still there. Fascinating to me. The original water sound suppression system that they used in 1961 is still there. It's a teeny tiny little fire hose compared to what you see now with like what NASA and United Launch Alliance, millions of gallons of water at the same time. It's fascinating to see how things have progressed. Alan Shepard did the first suborbital flight aboard the Mercury Freedom 7 in 1961. John Glenn launched on top, I believe that's an Atlas. Doesn't really matter. February 20th, 1962, so about a year later. What did he do? He orbited the Earth approximately seven times. He launched from Complex 14. Again, still all part of the Mercury mission. So Mercury not only did suborbital, they quickly moved to an orbital flight, and that was John Glenn. So that's the difference. Alan Shepard, yes, technically went into space. He only went up for a couple minutes, floated, and came back down. Kind of what they're doing at Blue Origin now, right? And who's that other guy? Super rich guy. Plane.
Virgin Galactic.
Virgin Galactic, yeah. Branson, yeah.
Yeah.
So Mercury had 1 astronaut on board. Gemini had 2 astronauts on board. How many do you think Apollo had? 3. 1, 2, and 3. And the missions got more complicated with time. The first couple Gemini missions were designed just to test people's ability to live in a tiny little capsule, no bigger than this space right here in front of Cassie. That's being generous. They couldn't even really get out of their seats. The SpaceX rocket that they launched now, they get a lot more room. They get a little toilet and everything. They didn't have that back then. So they ate as little food as possible before a mission, because guess what? Yeah, exactly. Gemini launches 2 astronauts on board, the first from Complex 19 in 1965. So when John F. Kennedy makes his proclamation that we're going to land a person on the moon, they are already thinking about that. They were already planning for the Gemini missions. Well, suddenly they realized, holy crap, we need to also think about what's it going to take to get to the moon. They kind of already were thinking about that, believe it or not. He wouldn't have made that proclamation if he didn't have some idea that there were scientists working on it. But look how long it took until we launched astronauts to the moon. That was Apollo 7, 1968, launched 3 astronauts on board from Complex 34. Now, obviously, they didn't go to the moon. They didn't go to the moon. You're right. They did tests that included orbiting the moon, but they didn't actually land. What was the Apollo mission that they actually landed? So in October 11, 1968, that was the first Apollo mission. In just 4 years, they completed 6 moon landings. Apollo 11, 12, 14, 15, 16, and 17?
No, I know 13.
13 didn't because of the oxygen tank or something happened on board.
Something happened with 13.
You gotta watch the movie. Who watched it?
I did watch the movie. I vaguely remember it though. I know
That's Bruce
something
Willis?
happened with Apollo 13, but I just don't exactly remember.
Trying to think.
It was a spark in the numbers to oxygen tank.
Oh my goodness, one over here. So, shame that I don't remember that movie to the tape. December 1972, the Apollo program comes to an end. After 11 crewed missions, so not everyone that went up actually went to the moon. Okay, 1 actually didn't make it, they actually had to turn around. Apollo 13 still went to the moon, but they just didn't land, they came around. There was a big gap between us sending astronauts into space between 1972, when the Apollo program concluded, and we launched the space shuttle, which obviously was in a beast of its own. Whereas this tiny little capsule right here at the top of this image on the Saturn V, this is a Saturn V rocket, the first full Saturn V rocket that launched with humans on board, Apollo 7. The actual astronaut portion is, you see that little dimple, that little circle? That part upwards. There's a little service module that's underneath of it that included like the lunar lander and stuff like that. And this, all here, is all the rocket propellant. So 90% of a rocket is fuel. The rest of it, whatever the payload is, in this case, human beings. Okay? 1981, they decided they wanted a reusable plane to be able to take off and come back. Plane, I'm using that word, loosely. The space shuttle launched in 1981 as a reusable space plane that would go up, do its thing, help build the International Space Station, and come back. That first launch was in 1981. The Space Shuttle Columbia, STS-1, launched from Pad 39A in 1981. So there's a big gap between 1972 and 1981, and I'll be honest, from the stories that I've read, there was a good chance NASA was almost going to completely give up on launching humans into space, but they persevered. Everybody knows probably, to some extent, the history of the space shuttle. Big incidents, what was it, 1985? 86, Challenger. 86?
It was January
86. And then Columbia in 2003.
Yeah, February 2000.
So Columbia was on its way back.
Yep.
Whereas Space Shuttle was on its way up. When the Space Shuttle was, after liftoff, one of the O-rings on one of the solid rocket boosters, which are these two large boosters attached to the main orange tank. Space Shuttle Columbia STS-1 is the only STS mission that you're going to see with a white tank. Believe it or not, every single mission thereafter was an orange main booster tank. Fun little fact. Anyway, the solid rocket booster that was on the side had O-rings in between all of the parts that kind of pieced together, and one of those O-rings collapsed in the cold weather that was present during the Space Shuttle Challenger mission, early January 1986. Kind of almost, they think that it kind of dry rotted. And then, so it was already in bad shape. And then the cold made it that less flexible. And so it failed. So anyway, that was Space Shuttle Challenger. Whereas Columbia was on its way back. It was damaged on the way up. Piece of the external foam from the main orange tank hit Columbia as it was going up. And they didn't realize anything was wrong until it was coming back. And obviously it broke apart over Texas, and its debris cascaded across the South in 2003. The last STS mission was in 2011 or 2012. I was in Key West at the time. October? What'd you say?
That's it with the rocket.
Yeah, it's 2011.
2011. Very sad day. Because I got to be at FIT for 7 years during the Space Shuttle era. So you can imagine what it would have been like to be here for a Space Shuttle mission. It was really amazing. So we've had about a 9-year gap until we started sending astronauts back up into space. And who did it first? Good old cocky Elon Musk. LC-39A, the same location that they launched some of the Apollo missions and the Space Shuttle Columbia mission, or Space Shuttle missions. He launched Doug Hurley and Bob Behnken up into space in May 30th of 2020. And we've had 3 crewed missions. This was the first test, if you will. Then we had Crew 1 and Crew 2. So we've already launched astronauts 3 friggin' times since May 2020. To me, that's really friggin' awesome. And this Sunday, we're launching 4 more astronauts. 2:15 in the morning. I get that right, Kelly? 2:18, something like that.
8:21.
I'm not on the mission, so I can care less. Thank God. I don't have the forecast for that
I
mission.
know, because
Is Arlene have to do that?
100%
Is
of me
Arlene
like
on that one?
Arlena.
Actually, never mind.
Is she on that one?
Arlene is in charge of that mission,
Oh, she's
actually.
in charge of that one.
So, you guys probably remember seeing this map, and I hope you guys get to see these spots in person. Cape Canaveral Space Force Station starts at Port Canaveral and works its way up all the way to Complex 41. There's a little dividing line right here. There's a little sign as you're driving north on this road that runs along the coast that says, "You're now entering Kennedy Space Center property. Get the hell out if you don't belong here." LC-39A and LC-39B are the only launch pads that are on Kennedy Space Center property. Otherwise, everything else happens at Cape Canaveral Space Force Station. So a lot of history occurred here until they started launching Apollo and shuttle missions from 39A and 39B. Okay? Some of the early missions, like Complex 19, is where they launched Gemini. Atlas, or the Mercury Redstone, was launched from Complex 5 way down here. So Alan Shepard launched from here. John Glenn was Mercury, Complex 14, right here. And then Gemini, Complex 19, and then Apollo up here. So that's kind of how things moved from south to north, I guess, with time. So they needed a bigger and bigger rocket every single time. So the facilities started off small and then got bigger and bigger and bigger. Some of the new programs that are coming on board, like Blue Origin, New Glenn, whenever they promised that they were going to be online by now, they've delayed another year. So things are going real slow for that program for some reason. They keep doing their thing out in Texas, but they can't seem to get their act together here in Cape Canaveral. I believe at the end of the next fiscal year, so fiscal year 22, is when they're planning on launching the New Glenn, which, by the way, is going to be as big as the Apollo Saturn V rocket. So that's going to be a beast. Our office, Morale Operations Center, oh, actually, yeah, it is right here. So this will be the closest we've ever been to a rocket of that size. So that's actually going to be really, really cool. Right now, when we see a Delta IV, Complex 37, a Falcon 9 from Complex 40, an Atlas V or a Vulcan, Vulcans should be coming online next year. United Launch Alliance is the other provider we have now. That's complex 41. Notice how far those sites are away from our office. But then here's going to be this beast that is the New Glen, and there's our office. So our car alarms are probably going to be going off. And yes, yeah, if we can line up a launch for you guys, we would definitely watch. We would attempt to watch from the NASA Causeway or the ITL Causeway. For a Falcon 9, you can watch from the ITL or the NASA Causeway. Delta 4, I don't think that's way too close to watch a launch there. Because all that they launch now are Delta 4 heavies as well. So that's three boosters attached. So it's and the next one's not scheduled to launch until 2023 anyway. So that's kind of the history. Now let's actually talk about the weather. I suppose that's what we're here for today. You guys probably have a general idea what the 45th Weather Squadron is because you've heard me speak, you've heard Arlena speak about this, so I'm not going to go into too much detail other than to know our mission is to basically exploit the weather to assure safe access to air and space. At the end of the day, we are responsible for the weather in the Eastern Range, and that includes, again, Cape Canaveral Space Force Station, Kennedy Space Center, and Patrick Space Force Base. And also some of our sites like JDMTA, which is Jonathan Dickens Park down in Martin County, Ascension Island, which is off the coast of Africa. Those are things that we're all ensuring that weather is cooperating. 3 individual flights within the greater Weather Squadron. WXR is our military presence. Those are all of our enlisted active duty members. Unfortunately, they have to work shift work, 24/7 operations. And they forecast for everything that's going on, all of the 3 sites that I mentioned, Space Force Base, Cape Canaveral Space Force Station, and Kennedy Space Center. If there's a day-to-day activity taking place, say they're moving a piece of hardware, they're moving a spacecraft, they're moving, they're flying planes, exercises out of Patrick, the active duty members are the ones providing that forecast. They're also issuing the weather watches, warnings, and advisories. So just like the National Weather Service issues forecasts for tornadoes and thunderstorms and things like that, they issue specialized forecasts for those sites that I've already mentioned. WXS is the group that I work for and Arlena works for. That's where all of the LWOs work, launch weather officers. And we provide support for generation, execution, and recovery forecasts of a mission. Mission is made up of 3 things, and that is the generation, execution, and recovery. Generation is when they're putting the rocket together. Execution is when they're launching it. Recovery is when we're helping bring that rocket back, if that applies to that mission. That's really only applicable now to SpaceX. Origin, I think, also wants to reuse theirs. United Launch Alliance lets their stuff fall into the ocean, as does Artemis, which is coming in February, NASA's mission, that those solid rocket boosters and main orange tank are just going to fall into the ocean and sink. So if there's anything that goes on that's related to a mission or a launch, that is where we come in. That is where the launch weather officer comes in. And then WXT is the people behind the scenes that basically make sure everything works. They are responsible for the most diverse and densest weather sensor network on the planet. This is WXS. This is our responsibility. So when a rocket booster arrives inside of an Antonov plane, believe it or not, that's how boosters come to us. The main solid rocket booster comes to us in the back of a plane or the back of a truck. Either way, depends how they ship it to us. SpaceX ships it on the back of a truck. United Launch Alliance sometimes utilizes the plane. When that booster first arrives, we're providing forecasts. When the solid rocket motors that you attach to the side arrive, we provide forecasts. When the second stage is put together, like you see in that third picture there, we provide forecasts. This is called the OVI, Offsite Vertical Integration. This is the top of the second stage. The Centaur rocket inside of a ULA is in here, and then part of the payload is in the top portion of that. That's basically the top half, the top quarter of the rocket, if you will. And then on launch countdown, that's the execution phase, we're also providing support. So every step along the way, if it involves a mission, we are there providing forecasts. On launch day, it's not just the LWO on console communicating with our partner. We've got a radar LWO who's designed to interrogate radar and satellite imagery. We've got a Recce LWO, which is a person that can communicate with a chartered aircraft to actually fly around and verify or confirm what the radar elbow is seeing. Why is that important? I'll get into that in just a little bit, but suffice to say the clouds that we interrogate that could potentially trigger lightning, it's very important to know their makeup and their thickness and their height. And so the radar can give us a little bit of that information, but there's uncertainty built into it. And so the recce aircraft, who is directed to fly by the recce elbow, there's pilots on board, and we just talk to them and say, hey, we need you to go 10 miles to the northwest of the pad, 15 miles to the southeast of the pad, things like that. That's the responsibility of the recce. We're also working on a Space Force base. So you have the LW, Launch Weather Director and Commander, that is communicating with everybody on the range. That makes up the launch weather team on launch day. You can imagine that being here in Central Florida, weather impacts operations here very frequently. From 1988, January 1988 through October 2021, we have had 724 countdowns on the Eastern Range, basically from Cape Canaveral or Kennedy. 64 have gone on to launch when we entered that countdown. We might have entered that countdown at 12 hours out, but we still launched that day. 259 of them scrubbed. In other words, we delayed 24 hours. So if you look at that, about on average, 2/3 of our countdowns result in a launch. About 1/3 result in a scrub. What is the most common reason for a scrub? Unfortunately, it is weather. Even though that percentage is less than other encompasses a lot of different things. Weather is the #1 reason for a scrub. On average, 47% of scrubs were caused by weather. Whereas if you launch on the same day that you enter the countdown, or the next day, across midnight, right? We launch on time, 334 out of those 465, but we've delayed also. And how can you delay? Either a launch occurs at an instantaneous window where you have to meet up at a specific spot like the International Space Station. And if you're going to the International Space Station, you have to leave the ground at the precise moment to be able to make it to the International Space Station. Whereas if you're trying to get a satellite in a certain spot over the globe, but it might be at this latitude or it might be at this latitude, or we've got enough fuel to move it back and forth once it gets to its intended location, you might have a launch window. And that launch window could extend 3 to 4 hours. So for those missions that have launch windows, we could delay. And sometimes we have to delay for weather. And in fact, we do. One of the biggest reasons of why we delay is, again, because of weather, about 30%. Lots of other reasons can be things like there's a problem with the rocket, or somebody entered the airspace, because the Eastern Range is there to maintain safety for a launch. So they're also monitoring the presence of planes and boats in the launch hazard area. Okay, so that's some other reasons why. Yes, we've scrubbed on account of that. In fact, I think back to Julia's SpaceX rocket not too long ago. It was the Polar Orbiting Satellite. What was that called? Transporter 2. They got down to the last 10 seconds of the count. It was an instantaneous window, and some asshole in a helicopter took off from Port Canaveral. And as soon as he got into the air, the people who track it saw the helicopter, and they had to call it foul range. And so the launch got canceled. Normally, it wouldn't have been an issue, because if the rocket was going on a northeast trajectory out into the Atlantic Ocean, no biggie. That Port Canaveral helipad is not in the launch danger area. But this was a polar orbiting satellite, so instead of going northeast, they were launching to the south, over land, close to land, very close to where the helipad was. So it was in that launch danger corridor, and as soon as it got aloft, they had to scrub.
Wasn't this a launch back in August?
It wasn't that long ago. Yep.
Oh,
Yep.
great. I stayed until 3:30 in the morning just to miss that one.
I am not surprised. Lightning launch commit criteria is what we do at the 45th Weather Squadron. Lightning launch commit criteria are a complex set of rules designed to protect against natural and rocket-triggered lightning. Again, you've probably heard this between Arlena and I, but I want to tell you a little bit about the history. Back in the 1950s and 1960s, I'll be honest, they didn't really give a crap about the weather. They wanted to make sure that there was no thunderstorm or lightning right near the pad, until Apollo 12 came along.
It's in the other one.
Where?
It went to Microsoft Edge.
Ooh.
For some reason.
Apollo 12. This is a live broadcast on NBC. Do we have sound?
We should.
Okay, I will go to 30 seconds just so you guys can see some of it. Hopefully people at home can see it as well. This is what it looked like on my coverage day of an Apollo mission, Apollo 12. 3 astronauts, Pete Conrad, Alan Bean, I believe, and Richard Gordon were the 3 astronauts on top. Oh, look who was there. Tricky Dick. Notice the camera. What are you seeing a lot of? And this is not just a result of the crappy resolution. Watch what happens when you see this take off. 11:22 in the morning. You remember something? 11:22. This is daytime, believe it or not. What happens? Disappears into the clouds. Very low clouds, too. Keep listening. Pete Conrad.
40 seconds. Altitude a mile and a half now, velocity 1,592 feet per second. Okay, we just lost the platform. I don't know what happened here. We had everything a little drop down. Roger. Plus one. Fuel cell lights, A2 plus light, fuel cell disconnect, A2 plus overload, 1 and 2, main plus A and B out.
Every single light on their launch console went out. Every single one.
SCE to auxiliary.
No, nobody did. We think it was an intra-cloud strike that struck. There was no cloud to ground. So, it goes on and on. This is Apollo 12. It's about 45 seconds into launch. The atmosphere was highly charged, but it was because a cold front was in place, and there was basically a layer of mid-level electrically active clouds. Not enough to produce lightning, but enough that when you send a rocket near or through it, you could trigger a lightning strike. And that's what happened in Apollo 12. Camera's very crude and things like that. They do believe that some piece of the lightning actually did strike the pad, so that's how they knew that eventually, they deduced that it indeed was a lightning strike. But the set of lightning launch commit criteria that we use today was bore out as a result of this accident. Call it an accident in the sense that it was struck by lightning and it should have never been, but they were able to recover and safely complete their mission. So even though they lost all of their controls for a solid 40 to 45 seconds after the lightning strike, they were able to push a reset button, go figure, a reset button on a rocket, and everything started back up, and they continued on their nominal trajectory. So some scary moments for the 3 astronauts on board Apollo 12, but before that, the lightning launch commit criteria was a stupid stay away from a thunderstorm. Then they realized, crap, we got to worry about all these other things, like clouds that are in the freezing layer, which I'll talk about here in a little bit. Things were going hunky-dory for, 20 some odd years, till 1983, Atlas Centaur something or other. Something happened with that rocket, but it still continued on its nominal trajectory. They believe it was struck by lightning, but because it got to its spot where it needed to in space, it properly delivered its orbit, its payload into orbit. There were no congressional inquiries. There was a congressional inquiry after Apollo 12. There was a congressional inquiry after Atlas Centaur 67. So 1983 kind of came and went. They said, maybe the LLCCs are all right. Maybe not. Who knows? 1987, They put it to the test again, and unfortunately it failed. Mother Nature won. About 45 seconds into the Atlas Centaur 67, which is exactly what it sounds like, Atlas on the first stage, Centaur on the second stage. Centaur is their second stage booster. Atlas is the first stage. 67 might have been the number of the mission. I'm not exactly sure. Other than to say it happened in 1987. Yet again, it was a cold front that was in the area that was leading to stratiform clouds and rain. Not cumulus clouds that when you look at a cumulus cloud and you see that it's really tall, you go, oh, that thing's electrically active. No, this was another benign light to moderate rainfall kind of day, but those clouds were connected to a thunderstorm all the way over in Orlando. And they didn't know that at the time. And so there was electrical energy being transferred into the stratocumulus deck. I mean, actually, it was more of a mid-level alto deck that was connected to the parent cumulus cloud out over Orlando. It was electric, it was highly electrically charged. And like I said, about 45 seconds into the flight, it triggered a lightning strike. How does it do it? You can imagine just a rocket sitting on the pad. There's an electrical, a natural background of electrical energy in the atmosphere. We call that the electrical field, background electrical field. In an undisturbed state without a rocket, you can have lower charges at the ground, higher charges aloft, or the vice versa. But as soon as you start sending a rocket through it, you start to disturb the electrical fields of the atmosphere. There's no clouds in this picture, but if there were a cloud, particularly in the mid and upper levels of the atmosphere, you get a mixture of water droplets and ice particles. And it's the rubbing together of those mixture of ice particles and water droplets that you start to build up electrical energy that then creates electrical fields inside of clouds. And then you start to disrupt those electrical fields, those enhanced electrical fields inside of clouds. And then on top of it all, you've got basically a toothpick launching through the sky made of metal that is connected to the ground via a hot exhaust plume. And it is that disturbance of the electrical field combined with this piece of metal that is connected to an exhaust plume to the ground that often triggers lightning, and that lightning travels through not just the rocket, but also down into the ground. So of the 10 lightning launch commit criteria that we use, only one of them is designed to avoid natural lightning, Mother Nature-induced lightning. The other 9 are designed to protect against rocket-triggered lightning, which is what happened in Apollo 12. Lightning would not have occurred if it wasn't for the presence of the rocket, and lightning would not have occurred during Atlas Centaur 67 unless there was a rocket going through it. So yes, we mess with Mother Nature in more than one ways. These are the 10 rules. The only rule designed to protect against actual Mother Nature-made lightning is rule number 2, lightning rule. Every other rule is designed to protect against rocket-triggered lightning. Surface electric field mill rules allows us to use a series of 35 electric field mill detectors spread across Cape Canaveral and Kennedy Space Center. If their readings come in too high and there are clouds overhead, we are no-go. If these readings come in high but the skies are clear, we can confirm that that is not a dangerous state of the atmosphere and we can send a rocket through it. Because you need there to be that mixture of water particles and water droplets and ice particles really to get that enhanced electrical field. So if there are no clouds overhead, that might just be the Earth's natural fields kind of being disturbed by something. We see field mills enhanced because of the sunrise, after heavy rainfall because of radon gas being released by the Earth. We see all sorts of funky things in the data, but if there are no clouds overhead, we generally assume it's pretty safe. If they fly a helicopter overhead one of the fields, if they're cutting the lawn by one of the field mill detectors, our numbers all of a sudden spike. But if there's no clouds over it, we know you're good to go. The cumulus cloud rule, the taller the cumulus cloud, the more in that mixed phase layer you're going to get. The 0 to minus 20 degrees centigrade, freezing level to about minus 20. Why is that? You get the super cool water droplets, again with the ice particles, rubbing together, releasing the electrons into the atmosphere. The taller you get, within 10 nautical miles, the further you want to be away from that cloud. So if it's a low cloud that only gets to about minus 5 degrees Celsius, you can be within about 3 miles of that cloud. If you get to minus 10 degrees, you don't want to get any closer than 5 nautical miles. If you get above minus 20 or at minus 20, you can't be within 10 nautical miles of the cloud. That's the breakdown of the cumulus cloud. There's anvil clouds broken up into an attached and detached anvil cloud rule. Attached and detached have long time frames. Why? Because you're sending all of this electrically charged particles high up into the atmosphere. So all of that energy is being deposited into an anvil cloud so it can maintain its charge for many hours. And we have standoff times that last as long as 3 hours for the attached and detached. So if that attached anvil starts in Orlando and slowly creeps towards us, even if the parent cloud is no longer there, we still have to assume that it's electrically charged and we don't want to send a rocket near or through it. Disturbed weather is for when there's cold fronts nearby and we see enhanced DBZs on radar around that freezing level, particularly greater than 30 DBZ, we have to scrub. Debris cloud rule are for those clouds that don't quite make it to the anvil level, but might be a little bit warmer part of the atmosphere. They too also have a standoff distance in both time and distance. Thick cloud layer rule, if you're anywhere within the 0 degree to minus 20 degree level, if your cloud is thicker than 4,500 feet, you're not launching. Because that cloud is thick enough, again, to have those two types of water particles, and there could be a potential for that enhanced electrical activity. The smoke plume rule is for cumulus clouds that develop as a result of fires, sometimes referred to as the pyro-Q rule. And then there's the triboelectrification rule, which is for the buildup of static electricity as a rocket goes up into the atmosphere. But every rocket that we launch from Cape Canaveral is treated for triboelectrification. So typically we only evaluate 9 out of the 10 rules. I see we're already past 8 o'clock, so I'm going to try and wrap it up here. How do we forecast the weather? Through one of the most dense and diverse operational weather networks in the world, for sure. There are over 400 weather sensors that include TDRIP, Terminal Doppler Weather Radar Profiler, or Wind Profiler, 48 megahertz wind profiler that can see the wind speeds up to 60,000 feet in the atmosphere. We launch weather balloons twice a day during the summer, 1 day during the winter. We have our own C-band radar, 5 centimeter C-band radar out off of 520. So if you guys are ever driving on 520 and see a little radar, that's ours. That's Patrick. We have 50 or 60 some odd weather towers that have weather sensors at multiple heights all across the Cape. We have 915 megahertz Doppler radar wind profilers. They measure the wind speeds closer to the ground, up to about 10,000 feet. FMQ19s, which are like ASOSs on our runways. This is what a field mill sensor looks like. And yeah, that's about it. 400 weather sensors throughout the area. That's it. Do you guys have any questions for me? Any questions online while we're here? I know, it's 8 o'clock. You guys want to go home. Nothing, Kelly? Nothing you can think of this time?
Yeah, Kelly, you're always full of questions.
Yeah, I don't want to bother and be like, wait, can we come
Oh my God.
That was gonna be my question.
That would have to work out with the school and with you. And so that there's probably some logistics to be involved with that. So we'll see.
We can work on it.
Yes. But I do think you could do that in the fall or the winter.
Hey, Will.
Right eventually. Hey, Mike.
I have to ask this. When Shatner went up to space, were y'all a little bit disappointed he didn't get sent up from Florida?
Yeah, of course we were. But, that was for all intents and purposes, that was a suborbital flight.
Yeah.
We're no longer in the suborbital flight game here.
Okay.
So, plus.
Maybe you can convince him to come back for a real flight.
Yeah. Now, supposedly, those of you, I think this, I don't think this is secret information. I think it was already announced. SpaceX secured a contract for Tom Cruise into space from LC-39A. He's going to film an action movie up in space. So we're going to have some celebrities eventually launch. So yes, I was disappointed that William Shatner was not here, but I think given the openness that space is now providing to any Joe Schmo with $50 million, I think, we're going to see some very interesting civilian-related missions out of the Cape here soon, which we just did, right? Inspiration 4. Here's a funny story about Inspiration 4 that had four astronauts on board. That was Complex 39A. That's SpaceX's only site that they can launch humans. Complex 41 or 40, that's Falcon 9, that's for Starlinks. 39A, they just launched Inspiration 4. That was 4 supposedly average human beings. One, I think, was a billionaire who paid for the rest of them. That was the first launch where we, the Weather Squadron, actually helped pick the time to launch. They gave us 3 days. They said, pick a 24-hour window where you think the weather's going to be best out of those 3 days. Then as we got closer, within 5 days, we had to narrow it down to a 12-hour window. And then when we got within 2 days, we had to pick a 4-hour window. So it was the first time the Eastern Range has ever been involved with actually helping the customer pick a launch time for a launch. And suffice to say, Inspiration 4, I think, went up. Is that the one at sunset that we saw?
Yeah.
The big plume, the big,
Yes, yes.
I'll call it what I think it is, shaped. And so that occurred right around sunset. So the weather was really nice. You got a question?
One crazy bit of happenstance during Inspiration 4 was the ISS happened to pass directly.
I saw that. Yeah, you're absolutely right. Who saw that? Did anybody see the launch? Then they saw the International Space Station. Yeah, now Inspiration 4 wasn't going to the International Space Station. They were just hanging out in space for 3 days. I don't think it would work out that way. I don't think you can launch and see the International Space Station at the same time. I don't think that would orbitally make sense. So, but that was really cool about Inspiration 4. I agree. Yeah. Since it's a manned crewed mission, sorry, LC-39A. Yeah, so unfortunately, as you can see, if you're watching it from around here, it's the furthest north site. So, if you're going to watch it, 2 o'clock in the morning, you definitely want to watch it from the water in Titusville. Yeah.
What if this squadron be helping out with Artemis?
Oh my God, yeah, that's Melody and Mark. Mark Berger and Melody Lovin. They are assigned to the NASA program, so they work specifically with them. I am assigned to United Launch Alliance, so Atlas Delta rockets, in addition to the Navy and Boeing. So our Melody and Mark are responsible for working with NASA, and they have been doing simulations left and right. They have a full dress rehearsal countdown. I think next week, if I'm not mistaken. And then they're going to roll the rocket out in December, do a wet dress rehearsal where they're going to fuel it. They're not going to static fire like SpaceX does, where they actually launch or where they actually light the rocket. They're going to do a wet dress rehearsal, and they're going to roll back in preparation of February's launch. So Artemis is coming, and Artemis is, I think, about 20% heavier than Apollo was. So I hope you're around for it. I hope it happens in February, but methinks it's not going to happen in February. I think it's going to be more like April, May. But we have to see how the wet dress rehearsal goes. The wet dress rehearsal is going to tell them a lot, because it'd be the first time they've ever fueled everything together in the main booster. Obviously, the solid rocket boosters are just that. They're solid kerosene, so it doesn't matter. But that booster in the center needs to be fully charged for the first time, and that'll be happening in December. So we're going to learn a lot. And because it's exposed, it's a 3-mile jaunt from the VAB to LC-39A. Because it's exposed to weather, there's a lot of work that goes into it. So they are on console and communicating with the customer for upwards of 12 hours. It's a very long day to roll it out to the pad. So by far the most weather-sensitive rocket, simply because it's being run by NASA, and they obviously are the most careful. Not to say that SpaceX and others are not as careful, but let's face it, I think Elon wouldn't care if he, killed a couple people or out on the pad, whatever. So,
A couple $100 million, not really. 3 people, absolutely.
Yeah, he wants to send people to Mars, and the first couple people that go to Mars ain't coming back. So, you got to be willing. You got to be crazy to work for him.
Hey, Will, another question from remotely.
Hello, Mike. What's up?
Yeah, so, Thursday, slight risk. models indicating some severe, perhaps tornadic potential. Do they ping you guys about those risk events? It's not too many days right before, the 31st. So how does that play out?
So you're right. It's not just about launch day. It's probably about 5 days in advance of launch. You can have a rocket out on the pad. And so, unfortunately, what are they calling this Dragon? Endurance?
Endeavor?
Is it Endeavor? It's E, right? So, whatever the capsule is on top of the Falcon 9, it is out there. It's rolling out. Today is Tuesday. It's rolling out tomorrow for static fire. Then they're going to leave it out there for a wet dress rehearsal on Thursday. So Arlena is not happy about that.
Oh, wow.
Given the threat of severe weather, they will leave the rocket out on the pad. It's able to withstand 60 knots. So
hurricane force winds.
I think given the forecast of, potential for 60 knot, it's probably something only like, less than 5%, but less than 5% of 60 knot winds is significant.
Yeah.
They're going to leave it out on the pad. So they are watching it closely. If wet dress rehearsal does not occur Thursday, it is not launching Saturday night. So I can also tell you that it's probably not going to launch Saturday night because of the abort criteria that they monitor up the east coast of the United States. They monitor weather sites off of Jacksonville, off of North Carolina, off of Nova Scotia, and off of Great Britain, off of Ireland. All potential sites where if something went wrong during the ascent, it would fall back to Earth, and they would have to recover it. Those ascent criteria, sea states, are quite low, only on the order of like 5 to 7 feet. And there's going to be a pretty healthy cyclone on our doorstep across the mid-Atlantic on Saturday into Sunday. So even though it might be fine here, I think Arlena was kind of hinting that she's only going to be like 10 or 20% POV for Sunday morning. Things are actually looking pretty good locally. They're not good northeast of us, out over the waters. And so lots of things are at play, not just what happens Thursday night, but also NASA Space Flight Meteorology Group is monitoring what's going on out over the waters. So yeah, a lot of things. So if it doesn't go Halloween morning, it's going to push to November 3rd. November 3rd, like 1:48 in the morning.
You don't say no.
Any other questions?
I'm not really sure how to ask it, but because there are more and more launches every year, is there a specific plan for what to do, like in hurricane season, when it comes up that blocks out a few days potentially, or not really? Like when
They will always.
Will things get in the way?
So the question was about, what's the preparation needed in advance of a tropical storm or a hurricane? They will plan things regardless of any potential threat for hurricanes, months in advance, even though we're going to tell them July, August, September, October are not a good time to launch in Florida because of hurricanes and the wet season, but they don't care. The frequency of those events are not high enough to preclude, doing billion-dollar operations. So they're going to continue those operations. They're going to continue to plan for them. We start issuing forecasts for every system that develops we use National Hurricane Center 5-day charts. And then if we need be, we can extend it out a couple days. We can give them guidance out to 7 days. We don't go anything beyond 7 days. If the wind speed probabilities within 5 days get to certain thresholds, certain customers take certain actions. Each one, it's all about risk tolerance. So SpaceX's risk tolerance might be a little bit higher than United Launch Alliance, which is mainly government contracts, and it's going to be certainly higher than NASA. NASA sometimes, Kathy Rice, who is the spaceflight or the meteorologist at NASA, she sometimes asks us questions before a storm is even named, and it's off of Africa, and it's like, whoa, give me a break. We don't, that's too far out. So yes, we take that information and we communicate the uncertainty and probabilities involved with that storm. We try and put everything in terms of risk to them. That's how we communicate. We don't just show them the 5-day forecast and say that's the most likely track. 2/3 of the time it falls within that track, 1/3 it doesn't. We show them wind speed probabilities, we talk about certainty, things like that. They make their decisions from there. We don't make the decisions for them. It's all about decision support services. They have to make those decisions.
Do you think in the future they'll come to you guys for input more, like you said, you were asking us the best opportunity, like it was a.
Yes, oh my God, yes, that's coming. And in fact, I just had a meeting with Project Kuiper, which is Amazon's answer to Starlink. They're about to send up a bunch of satellites as well for internet access, starting in 2024. And they started to ask us about launch window opportunities. And I asked them, are you going to be able to pick a launch window? And they say yes. So that's a big company like Blue Origin. Smaller rocket companies, which might not be dependent on meeting up with the International Space Station or going to specific orbits, things that only want to go into suborbital space. Even though I said we're not in suborbital business now, we probably will be. They can launch at much more, open time frames. So yeah, it's coming. Absolutely. I think so. The next Inspiration mission is February, I think, and that's going to be the same thing. We're going to help pick the time frame. All right, guys, 8:20. I've taken enough of your time. Another hour. You know how long I took on the January talk?
Yeah.
So, but hopefully you guys enjoyed it, and hopefully you guys online, as always, enjoyed it. It was good to see. Oops.
Or you stop share. You stop the share.
I'm not going to stop it, in case they want to say anything else. So.
Well, no, if you stop the share, you can see people.
Oh, I got you. Stop
Like
the
that.
share.
Oh, everybody has their cameras off. But yeah, we'll look into doing it in the spring, but if we do it in the spring, you're gonna have to be vaccinated because it's a field trip. So if you're not vaccinated, you cannot come.
That is a very good point.
That they will have to come
Be
on
on
the field
base.
trip. Like AMS, everyone had to be vaccinated. So we can look into it and do like the 15. But if you're not vaccinated, you're automatically out.
Last but not least, for those that attended, these are old space shuttle patches that they used to attach to their suits. So 4, 8, 12, 13, I brought 15. So for those that attended, you guys can take one from STS 123, STS 130, or STS 133. They're all basically the same, idea. They just look differently. So, and that means there's 2 left. So, Sandra, I would like to make sure that 2 of these, one goes to Mike and one goes to Stephen. Okay.
I'll make sure they go to them.
Okay, all. Thanks for joining me. I appreciate it, and we'll hopefully see each other in the spring. Bye, guys. Good seeing you too.
Thank you so much for coming.
Thank you.
You're welcome.
It was awesome.
I will.
Good seeing you, Dr. L.
It was nice. I enjoyed your talk.
Thanks.
Sherry, yeah. Do you want? I'm
Dinner
pretty sure
time.
This is the one you wanted.
You had dinner already. I haven't had dinner yet.
I haven't eaten dinner.
Just
Thank you so
take whatever is
much.
there. You're welcome, guys.
These are awesome. You did that one too? Yeah.
Oh, just Janelle said thank you. I think someone was asking.
Oh, yeah, yeah.
They will say thank you. Yeah, they said thank you.
Seeing you guys.
Sorry, I'm gonna end it. Yeah, you can end this. We're gonna do emails.